This is my geometry course. Today we're going to learn about proportionality theorems, transformations, and relationships between perimeters and areas of similar polygons. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by learning proportionality theorems. And the first theorem deals with triangles. This theorem says that if you have a line or segment, whatever you want to call it, that goes through a triangle that is parallel to another side, then that segment divides the sides that it goes through proportionally. So this side, these parts here are proportional to these parts. So what that means, remember, proportionality means that ratios are equal. So this side divided by this side is equal to this side divided by this side. So I know that seems kind of complicated, but don't worry. You'll see it's not too bad when we do practice problems. Now the converse of that is also true. That if you have a segment or line that cuts sides of two sides of a triangle so that the resulting segments are proportional, then that proves that these two lines or segments, whatever you want to call them, are parallel. So let's do some practice problems, and if you didn't get a screenshot of those, go ahead and do that. Just another triangle theorem. I know what you're thinking. You're thinking, not another triangle theorem. Well, in geometry, there's just a lot of triangle theorems. You got to get used to it. And keep in mind, I'm going to keep a record of all these postulates and theorems for you, so you don't have to do that. I'm going to give you screenshots of those before we take the next test. So we're going to find the unknown values. Now, we know that these lines here are parallel. How do we know that? Well, you see those arrows? That means they're parallel. So if they're parallel by this theorem here, this first theorem, if they are parallel, then that means that that middle line cuts these two sides so that the resulting segments are proportional. So what that means is 18 over 12 is equal to 15 over x. You could also flip both of those and write 12 over 18 is equal to x over 15. That's okay too. It doesn't really matter which way you do it. But remember, if you write something like 18 over 12 is equal to x over 15, that's wrong. This is wrong. So just make sure you got the right order. And how do you know the right order? Well, again, just memorize this side divided by this side over this side divided by this side. Or you can do it the other way. This side divided by this side over this side divided by this side. But each fraction has to have segments that are common to a side of a triangle. All right, so now the first thing we're going to do before we, remember, usually the method that students prefer is cross multiplication. There's a lot of different ways to solve these problems, but cross multiplication is the method that students prefer, so we're going to go ahead and do that. But before we do that, we want to reduce this fraction if we can. So I'm going to divide both sides by 6, and we get 3 over 2 is equal to 15 over x. That's a lot easier to work with. So now we're going to do cross multiplication. 3 times x is 3x, and 2 times 15 is 30. Divide both sides by 3, and we get x is equal to 10. So that is the answer. So pretty simple. Now in this problem, again, we know that these two segments, or whatever you want to call them, they're parallel. So if they are parallel, that theorem tells us that 14 over 12 must be equal to y over 18, or you can flip them. It doesn't matter as long as you flip both of them. So first we're going to simplify, divide both sides by 2, and we get 7 over 6 is equal to y over 18. And then again, we're going to, a lot of different ways to do this, but we're going to go ahead and just cross multiply. I don't want to confuse students by doing it different ways each time. So 6 times y and 7 times 18. 6 times y is 6y. 7 times 18 is 126, I believe. You can check that with your calculator, and you can use a calculator. Don't be afraid to use your calculator on some of these problems. That's okay. Remember, this is not really an arithmetic course. This is a geometry course. So y equals, divide both sides by 6, y equals 21. On to the next problem. We'll do one more of these before you try one on your own. So we've got, again, we know these two segments are parallel, so that means by that theorem, because we're dealing with triangles here, we know that a over 3 must be equal to 12 over 4. Or you can flip both of these. That's okay. So first we're going to simplify 12 over 4. That would just be 3 over 1. If you want to write the 1, you don't have to. For the cross multiplication method, you probably should, though. So a times 1 is a, 3 times 3 is 9, and there you go. So that's our answer. Now it's time for you to try some problems. So go ahead and try number 4, and I'll leave those in the window. And when you come back, we'll do it together. All right, we're back. So we know that these two segments are parallel because of those arrows. So because we're dealing with a triangle here, that theorem tells us that the sides are cut proportionally. And now we're just going to reduce 10 over 20 to 1/2 and perform the math, cross multiplication. And you should have b is equal to 28. So if you got that answer, good job. If you didn't get that answer, that's okay. Just figure out what you did wrong. And so on to the next problem here. Go ahead and try number 5. And when you come back, we'll do it together. All right, we're back. So those two lines are parallel. I know that because of the arrows. So x over 4 is equal to 21 over 6. And we're just going to reduce 21 over 6. Divide both sides by 3, and you get 7 over 2, it looks like. And now we're going to cross multiply, divide both sides by 2, and we get x is equal to 14. So if you got 14, good job. Now again, you may do it a slightly different way. You may do it as 4 over x equals 6 over 21. That's okay too. You'll get the same answer. All right, try number 6, and when you come back, we'll do it together. All right, we're back. 10 over y is equal to 15 over 12. We can go ahead and reduce 15 over 12 so the numbers are easier. Divide both sides by 3. And we get 5 over 4. Cross multiply, we get 40 is equal to 5y. Divide both sides by 5, and we get y is equal to 8. So if you got 8, good job. So that is the Triangle Proportionality Theorem. Again, if you didn't get screenshots of these, go ahead and do that. So now we're going to use the Triangle Proportionality Converse Theorem. What that theorem tells us is that if these lengths are proportional, if this side divided by this side is equal to this side divided by this side, remember, all proportionality, the word proportional, all that really means is that ratios are equal. The only hard thing is trying to figure out what ratios they're talking about. So we'll do these first 3 problems together. You can get an idea of how this converse theorem works. So what we're going to do is we're going to say 20 over 8, pretty much the same thing we did before. 20 over 8 is equal to 15 over 16, and we're going to see if this is true. If that is true, then that proves, by that theorem up there, that proves that these two segments are parallel. So is this proportionality true? Well, we'll just reduce it. Looks like that reduces to 5 over 2. If we divide both sides by 4, and divide both sides by 3 over here, and we get 5 over 2. So it looks like that proportion is true. So yes, the answer is yes, they are parallel. And I guess you can just rectangle this proportion because that shows that they're true. Or you can just rectangle this one. You know, any one of these proportions. Probably just be good to rectangle the original one. So that proportion shows that BE is parallel to DC. So for number 8, 50 over 90 is equal to 40 over 72. Let's see if that proportion is true. Divide both sides by 10 here, and we get 5 over 9. We're just simplifying to see if the proportion is true. Divide both sides by 8, and we get 5 over 9. So it looks like it is true. Or excuse me, these lines or these segments are parallel. All right, we'll try one more of these. 18 over 10 is equal to 24 over 15. Remember, don't get confused about which number goes where. And we're going to reduce, divide both sides by 2 on the left side, and we have 9 over 5. And then divide both sides by 3. Divide both sides by 3, and we get 8 over 5. So you can see it almost worked, but not quite. So this is not true, so we're going to put a cross through there, rectangle that, because that shows that they're not parallel. BE is not parallel to DC, so we say no. All right, so time for you to try. Go ahead and attempt number 10, and when you come back, we'll do it together. Remember, we're using the Triangle Proportionality Converse Theorem. So try number 10, and when you come back, we'll do it together. All right, we're back. So let's see if these ratios are see if these ratios are equal. Divide both sides by 5, we get 5 over 4. Divide both sides by 2, I guess, and we get 10 over 9. And it looks like we can't really simplify much. So it looks like those proportions are not true. So we say no. BE is not parallel to DC. So if you got that answer, good job. Try number 11. When you come back, we'll do it together. All right, we're back. 6 over 24 has to be equal to 8 over 32. Simplify, divide both sides by 6, you get 1 over 4. Divide both sides by 8, you get 1 over 4. So it looks like that's true. And we can say yes. DC is parallel to BE. So if you got that answer, good job. All right, for number 12, you see there's a decimal here. So it's okay to use a calculator, and you really do need to use a calculator. It's just going to be very difficult if you don't use a calculator, so that's okay. Just get out your calculator, use your phone, if you don't have a calculator on your phone, use one on your computer. Just access your calculator on your computer. If you don't have one on your computer, just go get a calculator wherever you can. Go get a calculator wherever you can find one if you don't have one on your computer or your phone. So attempt number 12, use the calculator, and when you come back, we'll do it together. All right, we're back. 8 over 5 is equal to 12 over 7.5. So I'm going to get my calculator out, and 8 over 5, I'm going to change to decimal form, and that is 1.6. There's a lot of different ways to do these, but I'm just going to change these to decimal form. 12 divided by 7.5 is 1.6. So when we change them to decimal form, we can see that this proportion is true. Another way to do it is to make these fractions look the same, but again, because we have a decimal, that's not so easy to do. So if you got that answer, good job. Now we're going to go to a different theorem. It's called the Transversal Proportionality Theorem. What this theorem tells us is that if two transversals are cut by 3 parallel lines, so there are 2 transversals, one here, and they're cut by 3 parallel lines, then the transversals are divided proportionally. So what that means, I know that sounds kind of complicated, but what it means is this length divided by this length is equal to this length divided by this length. So the hardest part about these proportionality theorems is just remembering, how to set up the proportion. The math is not too bad. So go ahead and take a screenshot of that theorem. That's our third theorem for today. Notice that this is a theorem that does not deal with triangles. So we want to find the unknown values. So it's really easy. Just 4 over 6 is equal to 6 over a. You can reduce 4 over 6 if you want. And by the way, you don't have to reduce. It just makes the numbers easier. Cross multiplication, we have 2a is equal to 18. Divide both sides by 2, and we get a is equal to 9. So, as you can see, it's very easy. Now for this one, I'm going to do 6 over 15 is equal to y over 20. Divide both sides by 3 on the left fraction, and we have 2 over 5 is equal to y over 20. And cross multiply, 2 times 20 is 40. 5 times y is 5y. Divide both sides by 5, and y is equal to 8. So again, these problems are not too hard. Let's do one more of these. And in this problem, one more of these before you try some on your own. On this problem, we're going to end up with, I think, a decimal or some sort of fraction in our final answer. So let's see here, we're going to reduce. So 8 over b is equal to 5 over 8. Cross multiply, and we get 64 is equal to 5b. Now I'm out of room. You're going to run out of room. That's going to happen often when you do tests and whatever you're doing in the academic world. Sometimes you run out of room. That's okay. Just use an arrow. Now we're going to divide both sides by 5. So you can use a calculator if you want. 64 divided by 5 is 12.8. So b is equal to 12.8, and there we are. All right, so go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. Z over 20 is equal to 9 over 15, and we want to go ahead and reduce 9 over 15, divide both sides by 3, and you get 3 over 5. Cross multiply, we get 5z is equal to 60. Divide both sides by 5, and z is equal to 12. So if you got 12, good job. All right, on to number 17. Go ahead and try number 17, and when you come back, we'll do it together. All right, we're back. I'm going to say 6 over 8. Again, there's many ways to set up these proportions, so if you're doing it a slightly different way, that's okay. And reduce. Cross multiply, 3 times 12 is 36. 4 times y is 4y. Divide both sides by 4, and we get 9. So y equals 9. If you got that answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. On to number 18. Go ahead and try number 18. And for 18, we're going to end up with a decimal. So you're probably going to want to use a calculator. So try 18, and when you come back, we'll do it together. All right, we're back. 8 over 6 is equal to 10 over x. Reduce 8 over 6, we get 4 over 3. Cross multiply, we get 4x is equal to 30. Divide both sides by 4, and we get 7.5, looks like. So if you got 7.5, good job. All right, on to the next theorem. We have one more, let's see, one more of these proportionality theorems, then we're going to get to something else. So again, I know what you're thinking. You're thinking, I can't remember all these theorems. Well, don't worry about it. I'm going to arrange all of them on one piece of paper or a series of series of pages, and I'm going to give you all of them. It's not going to be hard to remember them if you have them all in front of your face. So, don't worry about just getting overwhelmed with these theorems. You're going to arrange them at the end of I'm going to arrange them for you at the end of the course or before the next test or whatever, and you won't have to worry about it. The Angle Bisector Theorem tells us if we have an angle bisector, in this case a ray. Remember, an angle bisector can be a lot of different things, but in this case it's a ray. If this ray bisects an angle of a triangle, then it cuts this side so that these lengths, these segments, are proportional to the other sides of the triangle that are not cut by the ray. Again, I know that seems kind of confusing, but let's go ahead and do some practice problems. Go ahead and get a screenshot of that. And you'll figure out how this works as we do practice problems. So this is an angle bisector here. So what that means is that the side that it intersects, the side of the triangle that it intersects, if you take those lengths that are created, and you create a ratio or make a ratio, that ratio is equal to the ratio of the other two sides of the triangle. So 14 over 21. So how did I know the order? Well, again, it's just these sides, divide these sides, and then if this side is on top, the side that is touching it, that goes on top also. And if this side's on the bottom, then the side touching it, it goes on the bottom. That's how I remember. So let's go ahead and do this. We're going to divide both sides of the right fraction by 7, and we get 2 over 3. And then we're going to cross multiply as usual, and then we get 3a is equal to 30. Divide both sides by 3, and we get a is equal to 10. So again, it's just another proportionality theorem. So now 4 over 6 is equal to 8 over b. So 4 was on top, so the side touching it goes on top. And so now we're going to reduce 4 over 6, cross multiply, and we get 2b is equal to 24. Divide both sides by 2, and we get b is equal to 12. And next problem, we have x over 1.5. We're going to have decimals here, it looks like, is equal to 3 over 4.5. So that's okay. We can just use the calculator. Cross multiply. 4.5x is equal to 3 times 1.4 is 4.5. And divide both sides by 4.5. Looks like we won't have to use the calculator. Ended up being 1. So that's how to do these problems. You can see they're pretty easy. And it's time for you to try. You might want to take a screenshot of those if you want to use them to do the problems we're about to do. So number 22, go ahead and try 22. And when you come back, we'll do it together. All right, we're back. 12 over y is equal to 18 over 24. Divide both sides by 3 on the right fraction, and we get we get 6. Actually, divide both sides by 6, and we get 3/4. Cross multiply, we get 48 is equal to 3y. Divide both sides by 3, and you get y is equal to 16. So if you got 16, good job. All right, on to number 23. Go ahead and attempt number 23. When you come back, we'll do it together. All right, we're back. 6 over 3 is equal to x over 4. And we can just reduce 6 over 3 to 2, or 2 over 1 if you want to cross multiply. And cross multiply, we get x is equal to 8. So if you got 8, good job. Try number 24. You might need a calculator for number 24. And when you come back, we'll do it together. All right, we're back. 3.5 over z is equal to 5 over 12. Cross multiply, and we get 5z is equal to 3.5 times 12. That's 42. And then divide 42 by 5. I'm just using my calculator as I go here. And there we go. So if you got that answer, good job. If you made a mistake, that's okay. Just go back and figure out what you did wrong. Okay, so we're done with the proportionality theorems. Now we're going on to the second thing we're going to learn today. We're going to learn about perimeter and area of similar polygons. Now we're going to start with the Proportional Perimeters Theorem. So you can go ahead and get a screenshot of that if you want. And it's much easier just to explain with practice problems. So it says here, if the following polygons are similar. Okay, so we're assuming that these triangles are similar, or these rectangles are similar. So basically, they're similar. Okay, they're telling us they are similar. We know that they're similar. So what this theorem tells us is that if we know that two polygons are similar, then the ratio of the ratio of corresponding sides is equal to the ratio of the perimeters. So we're only given two corresponding sides, and how do I know that those are corresponding sides? Well, we can just look at the shapes. I can see that these two sides are corresponding. They're in the same relative positions. But be aware, sometimes they'll flip the shapes and try to confuse you. So I know that the ratio of corresponding sides is 16 over 20, or I can write 20 over 16. It doesn't matter, as long as this other ratio is in the same order. So I did the small number over the bigger number. So I'm going to write the small number, the small perimeter, over the big perimeter. So that's what the theorem says. So what you do is you find the ratio of corresponding sides, 16 over 20, and that ratio must be equal to the ratio of the perimeters. That's what the theorem says. It's pretty simple. Now I know that P1, we're given P1. It's 36 meters. So I can just plug that in. And now we'll just solve. So obviously we want to reduce 16 over 20, so divided by 4, we get 4 over 5 is equal to 36 over P2. Cross multiply, and that will be 180. You can get your calculator out if you want to. And 180 divided by 4 is 45. So, and in these problems we have to write units. So it's going to be 45 meters. Just because I gave units. And the other problems I didn't give units, so you don't have to write them. But sometimes you are given units, and when you are given units, you better write those units or you're going to lose points on a test or something. So 45 meters. And that is that problem. So let's try another one of these. Again, this is the theorem that we just looked at up there. The ratio of corresponding sides is also equal to the ratio of the perimeters. Now, if I didn't mention, you may have forgotten. Hopefully, you didn't forget. But if you forgot what perimeter is, that's just the sum of the lengths of all the sides. So, for example, if I'm going to buy a fence, I need to know how long the fence should be. I have to measure this side, this side, this side. Then I have to go to the hardware store, wherever I'm going to buy the fence, and I have to make sure that the fencing is that length. So we'll do, let's see here. We'll do a couple more of these before you try one on your own. So we're assuming that these rectangles are similar, and if they are similar, then the ratio of corresponding sides, 6 over 18, Notice we're not given all the sides, but we don't need all the sides. We just need the ratio of corresponding sides, so this ratio is going to be the same as all the other ratios. And that's the small number was on top, so P1, the small perimeter, is going to be divided by the big perimeter, but we have the big perimeter. To actually tell us what the big perimeter is, P2 is 126. So now we just reduce 6 over 18. And cross multiply, we get 126 is equal to 3P1. And then divide 126 by 3, and we get 42. And remember, you got to write those units. I almost forgot to write those units. So it's going to be 42 centimeters. All right, we'll try one more of these perimeter problems before you try one on your own. Again, if you didn't get a screenshot of that perimeter theorem, go ahead and do that now. So the theorem tells us that the ratio of corresponding sides, we have 12 and 8, so we know the ratio is 12 over 8, whatever that simplifies to. That must be equal to, and I don't have enough room, I don't have a lot of room down here, so I'm going to just, instead of writing P1, I'm just going to write 63, because I know P1 is 63. But again, if you're using the side from the bigger polygon, you have to do the perimeter of the bigger polygon in the numerator also. If you switch those around, you're going to get the wrong answer. So we're going to reduce 12 over 8. 4 goes in 3 times and 2 times. And cross multiply, and we get 3P2 is equal to 126. Divide both sides by 3. And we get 42. So that was just like the previous problem. That was a coincidence, I guess. So the perimeter of the second polygon is 42 feet. All right, so now it's time for you to try. Go ahead and try number 28. When you come back, we'll do it together. All right, we're back. So 4 over 6 is the perimeter, or excuse me, the ratio of corresponding sides. And then we have 14 over P2. And we're looking for P2. So reduce, cross multiply, we get 2P2 is equal to 3 times 14, which is 42. Divide both sides by 2, and we get 21 inches. Make sure to write inches. If you didn't write inches, go ahead and write that now. Remember, you're going to lose points if you don't forget, or if you forget to write your units. So if you got that answer, good job. All right, on to number 29. Go ahead and try number 29, and when you come back, we'll do it together. All right, we're back. 10 over 25 is equal to P1, which we don't know, over P2, which we do know is 30. And divide both sides by 5 over here. And cross multiply, and we get 60 is equal to 5P1. Divide both sides by 5. And we get 12 millimeters. So if you got 12 millimeters, good job. Again, this is called the Proportional Perimeters Theorem. All right, go ahead and try number 30. One more of these problems. And when you come back, we'll do it together. All right, we're back. So we have 45 over 27, that's the ratio of corresponding sides, and that ratio must be equal to the ratio of the perimeters of the polygons. So now if we divide both sides of this fraction by 9, we have 5 over 3. cross multiply, we get 5p2 is equal to, you can get your calculator out, multiply 3 times 135, and we have 405, then divide that by 5, and we have p2, the second perimeter, equals 81 inches. So if you got 81 inches, good job. All right, so we learned the Proportional Perimeters Theorem. There's also a theorem that tells us about the relationship between areas of similar polygons. So that's this theorem here. So go ahead and take a screenshot of this theorem. And it's like I said, it's much easier just to do a practice problem than try to explain. We're going to find the ratio of corresponding sides, just like we did before, 12 over 8. And then we're going to set that equal to the ratio of the areas. Now don't jump to conclusions here, because there's something I'm not doing. So A1, which is what we're looking for, over A2, which just happens to be 112. Now stop right there. Don't do this yet. There's one thing that we haven't done. There's one thing that's different. The ratio of the areas of similar polygons is not equal to the ratio of corresponding sides. It's equal to the ratio of corresponding sides squared. So that's the only difference. So now you're going to be tempted to go ahead and square this, and if you do that, it would be 12 over 8 times 12 over 8. 12 times 12 is 144, 8 times 8 is 64. That's how you would do that. But before you square that, let's make it easier on ourselves. Let's reduce the inside part first. Let's reduce this. So divide both sides by 4, and we get 3 over 2. Now those numbers are a lot easier to work with. So now if we square, 3 times 3 is 9, 2 times 2 is 4. You know, a lot of students are going to be really upset about this. They're going to say, well, wait a second, how did you do that? Well, I explained it in the previous step, but I can explain it again if you want to. We're just multiplying fractions, 3 halves times 3 halves. You multiply the numerators. 3 times 3 is 9, denominators 2 times 2 is 4. That's just, basic arithmetic we learned a couple classes ago. But that's the important thing, is to understand what squaring is. Squaring is just multiplying a fraction by itself. Hopefully you're not having trouble with that. If you are, it's okay to be rusty, but it's not okay to say I've never seen that before, because if you've never seen it, that means you're in the wrong class, the wrong course. All right, so now we're going to cross multiply, and we get 4a1 is equal to 9 times 112. So I'm going to get my calculator out. 9 times 112 is 1008. And then divide that by 4, and we get 252. So the other area is 252. And what are the units? Feet. So we have to write feet squared. So it's pretty much almost exactly like the perimeter problems. The only difference is you have to take that ratio of corresponding sides, and then you have to square it, because we're dealing with area here. Now you might be wondering, what's the proof of all these theorems? Well, there is a proof, but a lot of proofs in math courses you're not really expected to actually figure out, and so we're not going to waste a lot of time forcing you to do that. The important thing is that you know how to use the theorems. All right, so 32, we'll do one more of these, or actually 2 more of these problems before you try one on your own. So we're going to find the ratio of corresponding sides. And I'll put a divider here. So 6 over 18. But we have to square that. And that is equal to the ratio of, I think I probably should have written an extra step over here just for educational purposes. So 12 over 8 squared is equal to area 1 over area 2. So that just shows what exactly we're doing. So over here, 6 over 18 squared is equal to A1 over A2. And reduce 6 over 18. Actually, before we reduce, let's go ahead and plug in the known area. So A1 is 72. We have A2. Reduce 6 over 18, and we have 1 over 3. And then 1/3 times 1/3. That's 1 times 1 is 1, and 3 times 3 is 9. I'm going to cross multiply. 1 times A2 is A2. 9 times 72. I get my calculator out for that. 648. And don't forget to write your units. We have square centimeters. And by the way, if I didn't remind you, remember, we're dealing with area. That's why the units are squared. Square units are not the same thing as normal units. With square units, you're dealing with squares. With normal units, you're just dealing with length. Let's try one more of these problems. And again, if you didn't get a screenshot of that theorem, that's the theorem that we're using. One more of these problems before you try one on your own. So again, the theorem tells us that the square of the ratio of corresponding sides of similar polygons is equal to the ratio of the areas. So A1 over A2, and we know A2 is 160. So we're going to reduce, and we get 4/5. And square 4/5, and we get 16 over 25. And this is a situation where we just don't have enough room. Again, that's going to happen a lot. So just use an arrow there. And we cannot reduce 16 over 25. So we're going to go ahead and cross multiply. 160 times 16 is 2,560. And then we get 25A1. And divide both sides by 25. And we get 102.4 square meters is equal to A1. All right, so now it's time for you to try. Go ahead and try number 34. And when you come back, we'll do it together. All right, we're back. 4 over 6 is equal to, 4 over 6 squared is equal to 12 over A2. We can reduce 4 over 6 to 2/3. And then square 2/3, and we get 4 over 9. 2 times 2 is 4. 3 times 3 is 9. Then we're going to have to do an arrow. Cross multiply, we get 4A2 is equal to 9 times 12, which is 108. Divide both sides by 4. Again, you can use your calculator. 108 divided by 4 is 27. So the second area is 27 square inches. If you didn't put square inches, be sure to do that. Remember, if you're doing a word problem or any kind of problem that has units, your answer needs to have units. All right, so if you got 27 square inches, good job. All right, I'm going to leave those in the window. Why don't you go ahead and try, actually, let's go ahead and zoom in here. Go ahead and try number 35. And when you come back, we'll do it together. All right, we're back. 10 over 25 squared is equal to A1, which we don't know, over 175. Reduce, and we get 2 over 5 squared is equal to A1 over 175. 2/5 squared is 4 over 25. And cross multiply. 4 times 175 is 700. And then we we can use an arrow and divide both sides by 25, and we get 28. A1 is equal to 28 square millimeters. So if we got that answer, good job. Be sure and write your units. All right, go ahead and try number 36. Let me put a divider here. Go ahead and try number 36, and when you come back, we'll do it together. All right, we're back. So let's see here, 45 over 27 squared is equal to A1 over 612. That's what that theorem tells us. The ratio of the areas of similar polygons is equal to the square of the ratio of corresponding sides. I know it sounds complicated, but as you can see, it's not really that complicated. So now we're going to reduce 45 over 27, divide both sides by 9, and we get 5 over 3 squared. Five over 3 squared is 25 over 9. Then we're going to cross multiply. You can use your calculator on this. 612 times 25 is 15,300, and that is equal to 9A1. So we need an arrow. 15,300, divide both sides by 9, and we get 1,700. So A1 is equal to 1,700 square inches. So if you got that answer, good job. Okay, so now we're going to the last thing that we're going to do today, and that is transformations. All right, so transformations are when you basically take a polygon and you just do something with it. You throw it over there or flip it over there, rotate it. Translations are when you just kind of move the shape around, left, right, up, down. Rotation, that speaks for itself. You're just rotating it, the polygon. And reflection is when you take a polygon and you kind of flip it over a line. You kind of if this were a mirror, then you're kind of flipping the triangle over that line. And dilation is when you make something bigger or smaller. The shape doesn't change, but the size does. So it's important to understand that all these types of transformations, they don't change the size of the polygon or the shape. After you perform your transformation, the shape is going to, this triangle is congruent to this triangle. This triangle is congruent to this triangle. This triangle is congruent to this triangle. So these first three transformations, you don't change the size or the shape of the polygon. But the dilation, that's going to change the size of the polygon. But it's still going to be similar to the original polygon. So that said, again, if you don't have a screenshot, go ahead and get screenshots of that information. And again, to figure out how to do these transformations, it's better to just go ahead and jump into practice problems. So we're going to start with the easiest type of transformation, which is a translation. Now we're going to do transformations on the actual coordinate systems. We have coordinate systems here, grids. And there's special notation for translations. This is the special notation right here. What that means is you're going to take the polygon and you're going to move it 6 units to the right and 2 units up. So the way that we do this, the easiest way to do this is to take each point individually. So we're going to take A and we're going to move it 6 units to the right and then 2 units up. So 1, 2, 3, 4, 5, 6. 1, 2, and then that's our point. That's our new point right there. So that's how you're going to do this. You're going to do that with every point. We're going to call that A prime. And then we're going to do the same thing with C. 1, 2, 3, 4, 5, 6, 1, 2. and we're going to call that C prime. And it's very important that when you do the homework, you label these new points with a prime notation. B, 1, 2, 3, 4, 5, 6, 1, 2. And that's going to be called B prime. So again, for all these points, we went to the right 6 and up 2. And now I can get some different color here. Connect the dots. You don't have to use different colors if you don't want to, but hopefully it will help you see which. So this shape here is called the image. This shape is called the pre-image. Why do they use that notation? I don't know. Obviously pre because this comes before, but that's just the image, the notation you're going to need to learn. All right, so now we're going to do another translation, but now with a rectangle, and it says here down or to the left 4 and down 5. To the left 4 and down 5. That's what this notation means. When you subtract, you're going to the left or down. When you add, you're going to the right or up, depending on if you're adding or subtracting to X or Y. So now D, we're going to go to the left 1, 2, 3, 4. Oh, whoops, that's not the point. And then down 5. So 1, 2, 3, 4, 5. So that's D. So I'm going to label that as D prime. And then E, we're going to do the same thing to the left 4 and down 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's the next point. That's E prime. And you don't really have to do the rest. You can see what it's going to be. You go down 2 here. So you know you're going to go down 2 here. Sometimes you can use clues to make things go faster. And that would be F prime and G prime. And then you can just connect the dots. So we did, those are called translations. When you go up or down, or to the left or right, it's called the translation. So now I want you to try some problems. Try 39. And when you come back, we'll do it together. All right, we're back. So this notation here tells us to move to the right 1 and down to the left, or down 1. To the right 1 and down 1. So 1, 1. 1, 1. And there it is. So you write I prime. Make sure you write I prime and H prime. And connect the dots. And that is our transformation. So you can see we didn't really change the shape very much. We just kind of moved it to a different location. So if you got that answer, good job. All right, try number 40. And remember, you got to do each point individually. And when you come back, we'll do it together. All right, we're back. So we're going to go to the left 7 and up 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. And that is going to be K prime. And J, again, 1, 2, 3, 4, 5, 6, 7, and then up 2. So that point is going to be J prime. We're kind of going off the page here. Sorry about that. L, same thing, to the left 7. So 1, 2, 3, 4, 5, 6, 7, up 2. And that's going to be L prime. I know this seems kind of easy, but that's one of the reasons that I really don't like this stuff, is because it just seems like a bunch of tedious work for some really obvious stuff. So now we'll go to M, 1, 2, 3, 4, 5, 6, 7, 1, 2. Again, if it were my choice, I wouldn't make this part of the math curriculum. But for some reason, it's just become very popular. All right, and N is 1, 2, 3, 4, 5, 6, 7, 1, 2 again. Again, we're just going to the left 7 and up 2 in every one of these, for every one of these points. So that is N prime. And now you just connect the dots. And, because these are translations, Remember, the only transformation where you change the size is a dilation. We're not doing dilation. So this shape should look pretty much, it should look exactly the same as the pre-image. And you can see that it does. So if you got that answer, good job. All right, so those were translations. Those are the first type of transformation. We covered translations here. So now we're going to go to reflection. Reflection is a little more complicated, but still not too bad. Reflection is when you kind of flip things over. It's very important to understand that whenever you do a reflection, the reflection has to be about some line. So with translations, you could just translate whatever the directions tell you to translate. But with a reflection, you need a reflection line, and it tells us to reflect about the y-axis. So what that means is that we're going to take each point, and we're going to count how many units to the y-axis, and then we're going to go beyond to the other side that same number of units. So if we go 1, 2, 3, 4 units, we have to go past 1, 2, 3, 4 units to get our next point. So that is A prime. And you're going to do the same thing, 1, 2, 1, 2. So that is C prime. And then B, we have 1, 2, 3, 4, 5. So you're going to go past 1, 2, 3, 4, 5. And that is B prime. And you connect the dots and you're done. So we just reflected that triangle. We reflected it about the y-axis. And the reason they call it a reflection is because if you consider this to be a mirror, and say you're a person, here's your eyes and here's your mouth, and you're looking into this mirror, well, what are you going to see? Well, you're going to see eyes and a mouth looking back at you in that orientation. That's why it's called a reflection. All right, so let's try one more of these problems before you try some on your own. You're not always going to reflect about an axis. Sometimes you're going to reflect about a different line. So we're not reflecting about the y-axis or the x-axis. We're reflecting about a dotted line. So what we're going to do is we're going to count F. F is 1, 2 units to the dotted line. So we have to go 1, 2 units past the dotted line. So that point there is going to be F prime. Same thing with G, 1, 2, so we have to go 1, 2 past, and that gives us G prime. And then E is 1, 2, 3, 4, so we're going to have to go 1, 2, 3, 4 past. And I just realized I should write these letters probably above F prime and G prime. And this would be E prime, and then D prime, obviously, it's going to be down here. So again, 1, 2, 3, 4. So you have to go past 1, 2, 3, 4. These are reflections. So we reflected that rectangle across that dotted line, and there you go. So again, if you're looking into a mirror, like so, you're looking into this mirror, the reflection you're going to see is this shape. All right, now it's time for you to try some of those problems. I'm going to leave those in the window. So go ahead and try number 43, and when you come back, we'll do it together. All right, we're back. So we're reflecting about the x-axis. So what you're going to do is you're going to count 1, 2, 3, 4, 5 units to the x-axis. 1, 2, 3, 4, 5 units to the x-axis. So you're going to go past 5 units. 1, 2, 3, 4, 5. And that is your point for I prime. So that's I prime. And then H, you're going to go 1, 2, 3 units to the x-axis. So you have to go 3 units past the x-axis. And that is H prime. And connect the dots, and we reflected that segment about the x-axis. So again, if you're looking at a mirror and the x-axis is your mirror, then if you're looking from here to this way, the reflection you see is this this line. So if you got that answer, good job. Try number 44, and when you come back, we'll do it together. Be aware you have to reflect about the dotted line. So we're not reflecting about the y-axis or the x-axis, we're reflecting about the dotted line. So try number 44, and when you come back, we'll do it together. All right, we're back. It's 1 unit to the dotted line for j, so we go 1 unit past, and that gives us j prime. We have 2 units to the dotted line for m, and then 2 units past, so that gives us m prime. And for n, we have 4 units to the dotted line, so we go 1, 2, 3, 4 units past the dotted line. That is n prime. And then k, we have 1, 2, 3, so 1, 2, 3 past. That is k prime. And then for L, we have 1, 2, 3, 4, 5 to the dotted line. So we have 1, 2, 3, 4, 5 past the dotted line. So that is L prime. And then we just connect the dots. And after we connect the dots, there's a lot of dots here to keep track of. So don't be surprised if you make a small mistake somewhere. That's okay. But you do have to look at the shape and make sure that it looks right. If you're looking through this mirror here, are you seeing the right reflection there? And it looks like we are. So if you got that answer right, good job. All right, now we're going to go to rotations. When you translate polygons, you just move them. When you reflect, you need a line of reflection. And when you rotate, you need a center of rotation. And so our center of rotation in this class is always going to be the origin. We could do problems where the center of rotation is not the origin, but that would be a lot more complicated, and I just don't want to go into that much depth. I don't think this stuff is really that important when it comes to upper math courses. Also, if I didn't already mention, when you reflect, you can also reflect about slanted lines. But again, that's a lot more complicated, and I don't really want to go into that depth. Most geometry textbooks don't go into that much depth with this stuff. So we're just going to keep it simple and rotate about the origin. Now, if students have trouble with these transformations, usually it's the rotations that are a little challenging for students. Because you kind of have to picture, you kind of have to take your paper and rotate it. Also, I need to mention we're only going to rotate in increments of 90 degrees or multiples of 90 degrees. We could rotate angles that are not multiples of 90, but that would be much more difficult again, so we're going to stay away from that. But let's start with number 45 here. And what you want to do is you kind of want to take this whole page and just kind of rotate it 90 degrees. Now, it's important to understand that when you have a positive rotation, positive 90 degrees, you're actually going counterclockwise. Now, I know that seems wrong, but that's just the way it is in math. Counterclockwise is considered to be positive. This way is positive. And clockwise is considered to be negative. So we're actually going to rotate this way. And we're going to take each point and rotate. So C, that point is -2, -1. Now, whenever you rotate a multiple of 90, you always switch the x and the y value. So our C prime is going to be 1, 2. We just have to figure out what the sign is going to be. So you want to go out 2 and down 1, and then if you rotated this, you would end up, if you rotated 90 degrees so that the y-axis becomes the x-axis and the x-axis becomes the y-axis. If you rotated 90 degrees like that, then you would end up with something like, whoops, wrong button there. We'd end up with something like this. So our new point is going to be 1, -2. So our new point is here. That would be C prime. And then B, we go 1, 2, 3, 4, 5, and then down 1. So if you rotate that, we would go 1, 2, 3, 4, 5 over 1. And that would be B prime. And then A, we go out 1, 2, 3, 4, and then 1, 2, 3. So if we rotate that 90 degrees, that would be down 4 and over 3. So 1, 2, 3, 4, 1, 2, 3. And that would be C prime, or excuse me, A prime. Now we can just connect the dots. I'm just using whatever color I can find where it would stand out. Maybe we can use yellow. And there is our triangle rotated 90 degrees. So just kind of see if that would make sense, and it looks like it makes sense. So really we're just kind of using common sense here. So number 46, now we're rotating a negative 180 degrees. So that means you're going to be rotating clockwise this way. So in 180 degrees, that's two 90-degree rotations. All right, so for D, we go out 1 and up 1, 2, 3, 4. So if you rotate that 90 degrees to the right, then you go down 1 and over 4. And if you rotate it again, then we're going to go out 1 and down 4. And so that is our point, D prime. Now I'm going to do E. So now if we do E, we have 1, 2, 3, 4, 5, 1, 2, 3, 4. So if we rotate 90 degrees to the right, we go down 5, 1, 2, 3, 4, 5 over 4. And then if we rotate again, we go 1, 2, 3, 4, 5, 1, 2, 3, 4. And that makes sense. That's E prime. And we can kind of see what's going to happen here. We can pretty much just connect the dots at this point. And there we go. And G is going to end up over here, G prime and F prime, so on and so forth. But again, if you want to do it step by step, we go over 1, up 2, rotate that, and you go down 1 over 2, rotate it again 90 degrees, and over and down 2, so on and so forth. So that's how you do these rotations. So again, negative is clockwise and positive is counterclockwise. So again, this is kind of a challenge to see exactly what's going on. If you're having trouble understanding this, you can actually just rotate the page 90 degrees, and that'll show you exactly where where your point is supposed to be. If you're doing this, you should be doing this on graphing paper. So I'm going to go ahead and, well, I guess I don't have to leave those in the window, but go ahead and try number 47. Remember, negative is clockwise. So go ahead and try number 47, and when you come back, we'll do it together. All right, we're back. So we're going to go up 2. So if you rotate it 90 degrees clockwise, then it would be right here. Out 2. So that is H prime. And I, we're going 1, 2, 3, 4, 1, 2, 3, 4. So if you rotate it 90 degrees, you're going to go 1, 2, 3, 4, 1, 2, 3, 4. And there's our point. That is I prime. And we can just connect the dots. So if you got that answer, good job. All right, now 48 is going to be a challenge problem. I probably shouldn't have given you such a hard one just on your second problem here, but you will see a rotation of 270 degrees. One way that you could deal with this is instead of rotating it this way to get 90 and this way to get 180 and then this way to get 270, what you could do is just rotate it once 90 degrees in the negative direction. So that's an easier way to do this. So if you want, just kind of flip this page 90 degrees that way and you'll have your answer. So do your best. Take it point by point. And when you come back, we'll do it together. All right, we're back. So n goes out 2. So if you rotate it 90 degrees to the right, again, 90 degrees to the right is the same thing as 270 degrees to the left. So you have that point. That's going to be n prime. And then we have 1, 2, 3, 4. Rotate that, and then you have 1, 2, 3, 4. So that is m prime. And then L, we go up 1, 2, 3, and then over 2. So rotate that, and we have 1, 2, 3, and then 1. So that's L. L prime. And K, we go up 1, 2, 3, 4, and then over 1, 2, 3, so 4, 3. Rotate that, and you have 1, 2, 3, 4, 1, 2, 3. That's K prime. And then J, we go 1, 2, 1, 2, 3, 4, 5. So you rotate that, and you go out 2 and up 5. Out 2 and 1, 2, 3, 4, 5. And let's look at this and see if it makes sense, because it's always possible we can make a mistake here. So now let's connect the dots. And the question is, do we have the same figure? Let's study this. Let's look at it and see if it makes sense. I think it makes sense to me, so it looks right. So if you got that answer, good job. So now on to the last type of transformation. Again, the rotations, they're going to be a little tricky. So again, if you're not sure, remember, if you're not sure how to do the problem, just rotate the paper. Now, dilations are going to be pretty easy because we're going to dilate about the origin only. If you dilate about a point other than the origin, then it gets a little tricky. But again, we're not going to do that. So in order to dilate about the origin, what you do is you find these points, B. I'll just write them over here. Let me move this over. Point A, that is 1, 3. Point B is 0, -1. And point C is 3, -1. And it tells us here, dilate about the origin with the scale factor of 2. So to dilate about the origin, this is really easy. All we have to do is multiply all these numbers by 2. So A prime would be 2 times 1 is 2, 2 times 3 is 6. B prime, 2 times 0 is 0, 2 times -1 is -2. And then C prime would be 2 times 3 is 6, and 2 times -1 is -2. And so now these are the new points that we're going to graph, and we're done. So as you can see, this is pretty easy. So 2, 6, 1, 2, 1, 2, 3, 4, 5, 6. That is A prime. And then B prime, 0, -2, so that would be here, pretty close to B. And then C prime is 6, -2, 1, 2, 3, 4, 5, 6. Then we have C prime, so connect the dots, and there we go. So as you can see, this is an enlargement. Okay, if the figure gets smaller, it's called a reduction. If it gets bigger, it's called an enlargement when it comes to these dilations. So we doubled the size of the polygon. All right, so let's try number 50. D is 3, 6, and F is 3, 3, and G is 6, 3, and E, I think, is 6, 6. Yep, 6, 6. So now we're dilating with a scale factor of 1/3. So what that means is you multiply all those by 1/3. Again, when you dilate about the origin, it's really easy. When you dilate about a different center, then it's not so easy. So 3 times 1/3 is 1. 6 times 1/3 is 2. Now f prime, 3 times 1/3 is 1. 3 times 1/3 is 1. G prime, 6 times 1/3 is 2. 3 times 1/3 is 1. Sorry, I'm writing so small here. And E prime, 6 times 1/3 is 2. 6 times 1/3 is 2. So those are our new points. So 1, 2, 1, 1, 2, 1, and 2, 2. So as you can see, this looks like it's a square. This square got much, much smaller. We have F prime, G prime, E prime, and D prime. Sorry, it's kind of messy there. So as you can see, dilating about the origin is really very easy. All right, now time for you to try. Go and attempt number 51, and when you come back, we'll do it together. All right, we're back. H is -1, 2, and I is 1, 2, and J is 1, -1. So we're going to multiply by 3. So H prime is going to be -3, 6. I prime is going to be 3, 6. J prime is going to be 3, -3. Let's go ahead and plot those points. -3, 6. I have to shrink this stuff and bring it down. So -3, 6. That is H prime. And 3, 6. That is I prime. And 3, -3. That is J prime. And connect those dots. So as you can see, this was an enlargement. We tripled the size of that triangle. So if you got something like that, good job. All right, we have one more problem today. This is going to be a reduction because it's 1/2. So go ahead and attempt 52, and when you come back, we'll do it together. All right, we're back. So we got a lot of points here. P is 4, 6. Q is 0, 2. And O is 1, 2, 3, 4, 5, 6, 1, 2. So 6, 2. And M is 2, -2. And N is 1, 2, 3, 4, 1, 2. So 4, -2. And now we're going to multiply all those by 1/2. So 4 times 1/2 is 2. 6 times 1/2 is 3. And Q prime would be 0, 1. Again, multiplying everything by 1/2. O prime is going to be 3, 1. Sorry, I'm writing so small here. M prime is going to be 1, -1. And M prime is going to be 2, -1. So now we just have to plot those points. 2, 3. That's P prime. 0, 1. That's Q prime. 3, 1. That's O prime. 1, -1. That's M prime. And 2, -1. That's M prime. So now we can connect the dots. And it should look something like our original shape, except it should just be smaller, and it looks like it is. So if you got that answer, good job. So that is the class today. If you want to take screenshots of the work that we did to help you with your homework or to study for tests, go ahead and do that now. And screenshot number 2. And screenshot number 3. And number 4. And screenshot number 5. And screenshot number 6. And screenshot number 7. Screenshot number 8. And let's take screenshots of the homework now. Screenshot number 1. Remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. Screenshot number 2. Screenshot number 3. And screenshot number 4. So get that homework done completely and correctly and neatly, and be sure to put it in the right order in your binder. And I'll look forward to seeing you in the next class.